Assalamualaikum. Good day and hi. My name is Nurul Alia binti Muhammad Nasir. So for assignment 2 for Industrial Power Electronic BEKE3673, my group member is MT Afiq bin MT Yusaini. So we need to design of a feedback controller for switch mode power supply. So the question is, design a switch mode power supply that produces a variable DC output voltage of 0 volt to 60 volt from a single phase AC input voltage of 240 VRMS 50 Hz. The rated converter output voltage is 200 watt. The exceed 5 The output voltage ripple at steady state must not exceed 5%. State the transformer ratio if you use the transformer, and the switching frequency you use in your design. Specify the duty ratio, inductor and capacitor value using hand calculation. So the important point of our assignment is to first, to design the power supply, we need to consider the following parameters. So the first one from the assignment question is output voltage range 0 volt to 60 volt in DC, and rated output power 200 watt, input voltage 240 VRMS and 50 Hz frequency. Output voltage ripple need to be less than 5%. Switching frequency, transformer ratio, duty ratio, and inductor capacitor value that we need to show in our assignment. So for our design, first of all, we know to convert to get, we have 240 VRMS power supply, and we want to change it to 60 volt output voltage in DC. So first of all, AC input, we will step down, use a transformer, and then from AC voltage we're going to rectify it using rectifier, so we will get the DC output. So from DC output, we will use filter to filter the ripple and regulate to get a good DC output. So for hand calculation, we know that we use step down transformer. The transformer ratio is 16 to 3, that is 240/45. So we know that V secondary gonna be 45 VRMS, and V peak for primary is 339.4141. So V in will be 45 times 2, that equal to 63.64 volt. So we can calculate the duty ratio. So we get the duty ratio for 0.9428, and the resistor 18 ohm. So we set the switching frequency to 40 kHz, and we calculate the inductance minimum using the formula 1 minus D times R over 2 frequency, and we will get the minimum inductance 12.8 micro Henry. So the actual inductance is gonna be 10 times more. So the actual inductance gonna be 1.287 millihenry. So for capacitor, we use the formula 1 minus D over AL RF squared. So we will get 96.4 nanofarad of capacitance, and we're going to calculate the inductor current using this formula. V out 1 over R minus 1 minus 1 minus D over 2 LF. This is for inductor current minimum. So we get the inductor current minimum. So for the inductor current maximum, we change the 1 over R minus to 1 over R plus 1 minus D over 2 LF, and we get the inductor current maximum is 3.36. So we get the average inductor current to 0.03 ampere. So for current ripple, we use the formula V out times 1 minus D over 8LCF squared, and we will get the current ripple 2.16, that is not more than 5%. So this is the circuit for to change the 240 VRMS to 60 volt VDC. So we use MOSFET and diode, capacitor and resistor. So this is the graph from, and we'll see that the voltage measurement is 60 volt. The current measurement is 3.2 something, and the voltage is V in. This is V in, so 240, and we get the output voltage of 60 volt. So for block diagram, we use this is the signal. This is the program using PID, PWM, and buck converter. So for PID, we already calculate. We're going to calculate the KP and KI value. In PM, we're gonna put the VP value, and in buck converter, we will put all the value needed that we already calculate from hand calculation. So the first one, we assume the S value at 1000 and KI at 25. So KI over KP is equal to S, and we will get KP 0.025. So for the first one, we get the frequency crossover is 0.000745 kilohertz. That is so small, but the phase margin is 89.5. So we get the phase margin is 90, so it's not stable. But all of the zero and pole for this is at left of plane, but it's still not stable because of the phase margin. So next we need to improve the stability of our converter. So we need to improve to improve it, we need to make sure that phase margin is equal to 45. So from 108, we're gonna drag the point to 135 to get the 45 phase margin. So we're gonna get the new. So from previous graph, we can calculate the new KP and KI. So using the new KP KI, we can get the most stable converter. We still use the same block diagram. So I think that's all from us. Thank you very much.